Good afternoon, Pak Trividyo.
Iya, selamat siang Pak Riko.
Siang Pak Tri. Apa kabar Pak?
Alhamdulillah baik saya Pak.
Salam kenal ya Pak.
Ya, salam kenal.
Ini dari rumah nih Pak.
Betul Pak, betul WFA kami.
Sama Pak. Nggak ada yang berani ke kantor lagi.
Ya, kantor kami yang di WTC ditutup Pak. Jadi nggak bisa masuk mobil.
Oh. Jakarta nggak bisa ya Pak?
Di kompleks kantor kami pun nggak boleh Pak.
Oh
Bukan
gitu.
masalah masuk ke Jakartanya.
Oh gitu, iya. Sekarang memang lagi ini sih ketat banget, nggak bisa kemana-mana udah Pak.
Ya bagus lah Pak.
Iya.
Untuk kontrol movement.
Iya, semoga bisa inilah berlalu ini semua.
Amin.
Oh yeah, I think already joined with us Mr. Lancer. Hello Niels.
Yes, good morning. Hello, how
Hello,
are you?
good morning. You're in Belgium right now?
I'm in the Netherlands.
In Netherlands, sorry.
Yeah.
So it's still morning right now in Netherlands.
Yes, but not too early, so that's good.
So everything's fine there in Netherlands right now?
Fine. Yeah, I must honestly say we had some really serious water problems here because there was a lot of rainfall last days. So yeah, that's now getting better. So the sun is shining again, but
I don't know whether weather must be thankful for the weather or because the pandemic is better there.
Yeah, exactly. How is it there in Indonesia? Is it okay? Everything okay?
Actually, I might say it's not okay right now since we hit a new record every day, infections from the coronavirus.
Yes, sure, of course.
Yeah,
so, we are also in the Netherlands also very not that good at this moment. Very weird.
Yeah.
So but yeah, we will see how it goes. Yeah.
Okay, then I think I can start the webinar. Maybe the admin, can you check the system? Okay, is it already streamed? Okay. Something's wrong, I guess. Okay, great. Okay, I think we can start the webinar. Hello, everyone. Welcome to Petromindo's webinar, Hydrogen Technology, Production and Supply Chains Conference. My name is Rico Sihaan, and I will be your moderator as well your host for today's event. And during this time of pandemic, I also sincerely hope that all of you in a safe and healthy condition and wherever you are. So before we start, I would like to inform you several informations about the webinar. The first, that this webinar is open for questions or comments. You can post your question or comments in the Q&A tab in your Zoom application. So don't use the chat box. And we also we will discuss the question or comments that came in right after each presenter finished presentation. And secondly, this webinar is also broadcasted to Petromindo YouTube channel. So anyone who watched this in Petromindo's YouTube, you can post the question or comments in the comment section. So before we start, I think I'm gonna make a little bit introduction about our webinar today. I believe all of you, not a single day, not hearing about hydrogen in news. Hydrogen has been in spotlight for many countries, including Asians, And we also hear strong commitment from governments being stated to adopt the energy, hydrogen energy, as in either in very short term or medium term. So today we're gonna look at how innovations and inventions could help Asian countries, especially, and to expedite the use of hydrogen. These factors will play a crucial role on how to provide hydrogen in a sustainable, clean, and of course, cost competitive. The cost factor is likely will be dominant determinant for us in Asia, since many of us in developing countries are still struggling to get energy, let alone cheap and clean energy. So we will hear about hydrogen also can be utilized in power generation and how it can help the local community benefits from hydrogen. So today we're going to have three speakers that will speak to us. First speaker will be Mr. Trividyo Pramono, President Director of Air Products Indonesia. Second speaker will be Mr. Niels Lancer, Commercial Director of High Gear. And the third speaker is Mr. Matthew Gies, Vice President of HDF Energy. Each speaker will get 30 minutes in total for presentation and Q&A. So maybe 15 to 20 minutes for presentation, and then followed by Q&A. So, and then at the end, we're going to have a panel discussion where we're going to talk about how to enable the hydrogen as energy. We have Mr. Niels Lancer and Matthew Gies as the panelists. So in total, this webinar will take duration approximately 1 hour and 45 minutes. So yes, we do encourage all of you to be active in this event. And you can post it in the question and comments. So please don't wait until the entire sessions are over. You can submit your questions actually now, and I believe you already have in your mind right now. So without further ado, I would like to introduce our first speaker. He is Mr. Trividyo Pramono, President Director of Air Products Indonesia. A little bit introduction about Mr. Trividyo. He has been the President Director of Air Products Indonesia since 2010 until now. So he has been 11 years working at the Air Products. Please, Pak Tri, this virtual space is yours.
Yeah, thanks, Pak Rico, and all the people who dialing in for this webinar for the hydrogen technology production and supply chains. How are you going to run this webinar, Pak Rico? Are you going to show my slide, or you let me to share my own slide?
Better you can show it, Pak, because it will be easier, I think.
Okay, give me a minute, yeah.
Okay, Pak.
Can all of you see my screen now, Pak?
Yes, clearly, Pak.
Okay, thank you, everyone. Let me start with Air Products. Air Products is one of the world-leading industrial gas company where we have experience and expertise as well in hydrogen. So we are the market leader in the hydrogen. So as part of the whole agenda with a 30-minute slot that provided by Pak Rico from Petromindo, I have to capture all the slides here quickly in 20 minutes, and then we have sometimes for Q&A. So overview of the company and capability, experience, and then last one will cover the mega project that AP are having around the globe. So now comes to the company overview. So the company focusing in the three drivers area, where in energy, environment, and emerging market. So these three business driver will be a focus for AP, for the company. After in the business for more than 80 years, we are listed as a US Fortune 500 company and in the leading position for the diverse market. So this a little bit about the summary of the company by last year, fiscal year 20. 8.9 billion in revenue, operates in 50 countries with 19,000 employees, serving different industry, more than 30 types of the industry. And we have market capitalization over 60 billion. We operate 750 plus of the production facility, and we're having 1,800 miles of industrial gas pipeline. So that's a large amount of the pipeline. The accomplishment in the sustainability, as Pak Rico mentioned earlier, that hydrogen should play instrumental contribution for the sustainability development. And this part of the accomplishment of the company of Air Products, which become our business strategy and track record of execution to continue increasingly our ambitious of sustainability growth and goals here. So talking about 50% of the revenue from the sustainable offering, so it's not small for the company. And more than 1 million metric tons of equivalent CO2 avoided through efficiency improvement, not only in our own operation, but also we are working together with the customers around the world on how to improving their process and reducing the emission. So we have 27 million workers hours without LTI in one of the large project that just completed in Saudi Arabia, Jazan ASU project. That's some of the accomplishment in the sustainability that I can tell for the webinar audience here. And next one is what, again, we are having the three business driver for the company. And hydrogen is one of our main business here. We are Air Products as the largest supplier around the world in terms of the revenue on the sales of the hydrogen. And we are also the largest LNG equipment technology providers, as well as the developers of the LNG. Using the oxy fuel burner, we are helping the customer to reduce their emission, where we design, doing the research and develop the burner for typical industry to meet their requirement in reducing the emission, as well as productivity improvement, and also fuel saving or cost saving. Next will be same drivers that we're talking about, and this becoming our company theme right now. Gasification for today, carbon capture for tomorrow, and hydrogen for mobility will be day after. So since we are talking about the hydrogen, all of these processes are related with the hydrogen processes. And as end product, hydrogen can be used as energy to drive the transportation equipment, car, buses, trucks, rails, and so on. So this is our company target, which is quite ambitious in terms of the carbon intensity goal. third by 30, meaning that by 2030 we will cut the emission from 114 in the base period 2015 becoming 76 by 2030. This is quite ambitious from our CEO, but we are having some activities and plans on how to achieve this. And these are some of the plans and strategy that the company are doing over the almost 10 years from now, to reach that third by 30 carbon intensity goal. One of them is carbon capture project, carbon-free hydrogen. They're talking about green hydrogen, low carbon project, which are going to use small or low carbon content for this process and project. We are also improving our operational and doing some improvement for efficiency of the operation team as well to get alignment with the target for the third by 30. Last one is we also utilizing the renewable energy to meet this one. This slide will talk about Air Products Indonesia operation. We are small here with total employees 130 plus, nearly 30 years operation in a country with our headquarters at office in Cikarang, and 2 million accident-free hours as of 2020. This is a proof of our commitment to safety. Same like what we presented earlier in other project where we achieve a lost time incident, zero lost time incident. So this just a milestone from the beginning that the company entered the business in Indonesia back in 1992 until the 2020 where we already almost 30 years, and the company made the agreement to build the first world-scale coal-to-methanol project in Bengalon, East Kalimantan. This is what we mentioned as our theme in the company for sustainable growth, for sustainable future. In today, we are working on gasification. So now come to the capability and experience of Air Products for the hydrogen sectors. As I mentioned earlier, Air Products has a hydrogen leadership for this one already experienced 60 years, and we are at the forefront of hydrogen energy technology and development. So this slide will give us some flavor of Air Products as a world leader in hydrogen. So as a world largest hydrogen producer, so we are not only developing the technology to produce the hydrogen, but we are producing hydrogen itself and become the largest. We own 1,100 plus kilometers of pipeline of hydrogen, which is the longest hydrogen pipeline in the world, supplying more than 3.5 billion norms per hour hydrogen. We have for the hydrogen car or hydrogen fuel cell electric vehicles, already 15 plus years in the experience in the world, with more than 250 hydrogen refueling system project worldwide, and more than 30 hydrogen electrolyzer project we have around the world. Working on the plus more than 20 countries, and production starting from the SMR, gasification of gas, of course electrolyzers, and at some point that we need to liquefy the gaseous become the liquid, which make easier and more economics to transport in the large bulk volume. Distribution methods, we are using pipelines, liquid trucks, and gaseous trucks in the tube banks. So this one is on the right-hand side, this picture of one of our latest project in Kochi, India. This supplying the hydrogen for the refinery in India. We are becoming the world leadership position for the outsourced hydrogen production and recovery. We build, own, and operate the hydrogen plant since 1993, and now more than 250 hydrogen station project, more than 20 countries. And this Kochi for the refinery hydrogen capacity in total is like 16 tons per hour of hydrogen. It's a huge capacity over there. And product is a member of Hydrogen Council. This is talking about that one in the slide. And main industrial application for the hydrogen, you can see in this slide that can use hydrogen for hydro treatment or hydrocracking of petroleum product, synthesis of ammonia, oxo alcohol, and so on, including methanol and its derivative product, hydrogenation of vegetable and animal oil to produce the margarine and other fats products. High purity hydrogen is used in the electronics industry as a reducing agent, as well as in metals industry as well. As carrier of flame gas in a gas chromatography, this all some of the application for the industrial. Also used as a reducing atmosphere. Liquid hydrogen is used as a rocket fuel, as you can see in the picture in this slide. So many variety of the application for the hydrogen for the industry. So we are leading a global hydrogen provider. As a feedstock, it can be came from the fossil fuel or renewable energy, and production can use like gasification process, SMR, on-site generation. The renewable energy is like one process is electrolyzer, where the power is supplied by solar, wind, or hydropower. So this next slide talking about hydrogen fuel in Indonesia. So this we can see that hydrogen can be generated from the water as a clean product. No greenhouse gases emission for this hydrogen as energy. And having the higher energy density than batteries when compressed, which the benefit of the hydrogen and can be easily produced from many energy sources, as I mentioned earlier. That can be from fossil or from renewable energy. This block diagram also can show you on the left-hand side, on the top one, all the greens. That's a renewable energy, and the blue ones on the bottom, that's a fossil energy source. And through the processes in the middle, we can produce the hydrogen as a final energy. And this is the facts, opportunity and challenge in Indonesia. The facts that we have abundant potential source to generate hydrogen in the country. Either we call it the gray, blue, or green hydrogen. We can name it. So we can classify it in each category. The opportunity is the implementation hydrogen as a future energy, which will lead to a significant contribution to the country commitment in reducing carbon emission. This one is a main theme right now for like a net zero or reducing the emission of the greenhouse gases. The problem, the challenge is in a country, we don't have a special policy related with the hydrogen at the moment. And we expect that the regulators, the government start looking at hydrogen as an alternative renewable energy, which is good to be developed in the country for any different application from the industry until for the transportation, also generating the power. Yeah, this same like the previous slide. I just want to mention that Indonesia have a target of the reduction 29% GHG emission by 2030. This what we call it as NDC, nationally determined contribution, and net zero by 2060. As a result of that PLN in the latest draft of the general plan for electricity supply, they changed the policy from earlier 2019-2028 using the new and renewable energy with 30% portion and fossil energy 70%. To the new policy which is now drafted and NRE become higher, much higher, 48%, and fossil energy drop to 52% from the aerial policy. So hydrogen can play a part, a significant part here to achieve this policy. If the government have put in place the regulation to support this hydrogen use and development in the country. And this just give a table that's showing the 29% target as I mentioned earlier in the NDC. This just showing the another evidence that market are doing the same trend to the hydrogen growing momentum and also interest in the hydrogen. Next, I will talk about the hydrogen mega project that are doing by Air Products. This is NEOM. This green hydrogen, carbon-free, producing 650,000 kg per day of carbon-free hydrogen. Eliminates over 3 million tons of CO2 CO2 emission annually and smoke forming emission, which is equivalent to over than 700,000 cars. This best available technology for providing carbon-free hydrogen to the world. And this is the first project in the world for the green hydrogen. This is a block diagram that showing the NEOM project, the green carbon-free hydrogen. So the power supplied from wind and solar facility, and then that will supply the power to electrolyzer and convert the water into the hydrogen with nitrogen produced by ASU. It's going to feed the ammonia production to produce the ammonia, which will carry the hydrogen energy and for the global distribution around the world. And at the refueling station, we're going to have ammonia dissociators, which will dissociate ammonia, become hydrogen, and compress it to the high pressure to be stored in the container at each transportation vehicles. So this picture of the hydrogen for mobility by Air Products around the world. The refueling system the type of the transportation vehicle that now are using the hydrogen. This one also the smart fuel hydrogen fueling technology that we have. In these things, we are also using the liquid hydrogen, as you can see at the lower right bottom corner. There is a tank. And this just talking about the hydrogen asset acquisition done by AP in the last year, which showing our focus in the business driver that we are focusing on the three area: energy, environment, and hydrogen for mobility. So we are acquiring the asset from PBF Energy in US, and we supply to the 5 of their refineries in California and Delaware. There's another project in the Gulf Coast that we also doing the SMR and ASU to produce the ammonia. In this process, there are hydrogen and nitrogen production as well. But the feedstock here still using the NG, so the ammonia cannot be called same as a NEOM project as a green ammonia. This year we call it the gray ammonia. This is the last slide, I believe, that sharing the latest project that developed by AP with our partner in Western Canada, is talking about net zero hydrogen. So in the left-hand side, with the autothermal reformer, AP capturing 95% of the CO2 for the sequestration purpose. The amount of this that can offset the CO2 emission that produced by other hydrogen plant that's supplying the pipeline for this all complex. So we use hydrogen for the power plant, and power will drive the compressor for the ASU, and also supply the power requirement for the AVR. And some of them liquefy in terms of in the form of the liquid hydrogen, and supplied in the 55 pipeline kilometers pipeline in that complex. So that's what we have so far in the works. And as I mentioned, this is the last project that I want to share, and the last slide that I want to present in this webinar. So thank you, everyone. Thanks, Pak Riko.
Okay, thank you, Pak Tri, for your presentation. I think we can straight forward to the questions, Pak, because there are so many. I don't know why it came so fast. The first question is from Pak Andre, Pak. The question is, how Air Products see hydrogen produced by electrolysis? Can it compete with hydrogen produced from SMR? And the second question is, will Air Products develop its own hydrogen stations if fuel cell cars available in Indonesia? Please, Pak, go dulu.
Okay, thanks, Pak Riko and Pak Andre Abioso, who raised this question regarding the hydrogen. Yes, comparing the electrolysis process with SMR, it's at a certain dimension or capacity. It depends on how much is the feedstock for the SMR it costs, and for the electrolyzer also how much the power cost will it be. So the technology itself is competing each other, but the main cost stack contributing to the economics of each process is the feedstock for the SMR and the electricity cost for the electrolyzer. If you build electrolyzer like what we do in a NEOM city, like a huge electrolyzer, which AP working with ThyssenKrupp to develop that project, then it will be economics. Again, the cost of the electricity will be important here, and the cost of the feedstock of the SMR, like the natural gas or a hydrocarbon. If the hydrocarbon feedstock is so much high in a certain location than electricity cost, then you can weigh which one is will be economical. That's my answer for the first question. And the next question, will Air Products develop own hydrogen station for fuel cars? Okay. Yeah, we need to get regulatory to issue any regulation to have certain incentives for this new technology to be competitive and economical and acceptable and affordable for the market. Yeah, Pak. In many countries, we have put it hundreds of the hydrogen refueling station in total. Yeah, in my slide, the 250, more than 250 in more than 20 countries. So it depends on the regulation available, whether that's will be providing enough incentive, similar like electric car now, electric vehicle. Yeah, without the proper incentive of enough incentive, then this electric vehicle will not be competitive compared to the gasoline car. Yeah, so we need to have that regulation by the regulators, by the government. But AP will be willing to invest on the hydrogen station, of course, if the business will make sense for us to do that. Like in other country, yeah, in US we have many refueling station. In Japan, in China, in Singapore, we also have few refueling station for the hydrogen. I think that's for the two questions, Pak Rico.
Okay, Pak. Maybe a little bit exploration for the first question. What do you see, Pak? Your own view, if we compare the hydrogen from electrolysis and SMR, particularly in Indonesia, Pak, knowing that right now we are oversupplied both in natural gas and also electricity. What do you see, Pak?
Yeah, if you talk about the current period, Pak Rico, my straight answer, the SMR will still be the first choice for the industry or for the market over the electrolyzers. Because the electricity price still high here, and the end of this feedstock is quite easy to get. Yeah, the NEOM project is a green hydrogen, but it cannot be compared with the brown or gray hydrogen, or even the blue hydrogen produced by the SMR. Of course, there are the incentive from the green hydrogen, but no emission for the sustainability. So if you're asking about the price competitiveness, the green always green product always higher than the blue product, and the blue product always higher cost than the gray hydrogen or gray product. So that cannot be a question anymore, but that is for sure that's the answer. Then, but since the people now is demanding for the lowering or decreasing or reducing the greenhouse gases emission with the target from the Paris Agreement, like 1.5 degrees C only, then now people have to start shifting from the gray to the blue, even to the green. And that's why there is a net zero target for all the countries who are ratifying this Paris Agreement, Pak.
Okay, okay, Pak. So based on our current electricity cost, ya Pak, still not competitive to beat the SMR ya Pak ya.
Yeah, exactly, Pak.
Okay, okay, Pak. The third question, third question from Pak Ahmad. The question is, Pak Trividyo, what do you think would be the threat and challenges of doing hydrogen business now and the future, and in Indonesia and around the world? Silakan, Pak.
Yeah, thanks to Pak Ahmad for this question. Hydrogen in the normal current days is not an issue to market and doing the business here. Many application for the hydrogen. Yeah, the refinery using the hydrogen, a lot of hydrogen. Some of the electronics industry also using that, metals refinery also using hydrogen. So when we talk, the challenge is more on how to have the blue hydrogen or green hydrogen in the country. If we are only talking about the gray hydrogen like what we're having now, it's only talking about the technology is there, the economic, there are some example in the market, not an issue. And the challenge is more on the blue hydrogen or green hydrogen. Blue hydrogen is talking about the CCS or CCUS technology need to be integrated in the SMR or ATR or POX technology that use typically to produce hydrogen from hydrocarbon product, from hydrocarbon feedstock, sorry. So the challenge is more on that area, and the threat is more on that area, not for the gray hydrogen.
Okay. Okay, maybe because of time constraint, Pak, I will take directly two questions from Mr. Driessen. The question is there any business model for air products to use CCUS, Pak, carbon capture, applied in blue hydrogen and use this carbon as building blocks for the chemical industry? And second question from Pak Ahmad lagi, the question is, with the rapid development of battery technology, what is your opinion, Pak, about the development of electric cars such as Tesla? And do you think that this will be a threat to you achieving your vision, hydrogen for mobility? Silakan, Pak.
Okay, quick answer to the Pak Driessen question. Yes, we do have the business model for AP, for CCS, CCUS, and we apply it in the US already, none in Asia yet. If we have this gasification project and government force us to do the CCS, that will be coming here in Indonesia, that business models. And that can be used not only in the refinery or chemical industry, that can be used elsewhere in any different type of the industry.
Okay, Pak.
Next question
is about Tesla, Pak. Tesla with batteries.
Yeah. At the current moment, the famous discussion is around the EV car, electric vehicles. Yeah. We should not make the competition between the electric vehicle with hydrogen fuel cell electric vehicle, because both will need the battery. So even for the hydrogen fuel cell, we also need the battery in the car to store the energy that produced from the fuel cell, and this battery will drive the car. The difference between the electric vehicle, it will require a big size of the battery, because the main main energy coming from the battery itself. After being recharged in the battery charging station. The difference with the hydrogen fuel cell, the primary energy is coming from the hydrogen, which converted in the fuel cell, becoming the electricity, and it will be stored in the battery. But the size, the dimension of the battery, it will be much smaller. And in terms of the energy density, after the hydrogen compress in its container in the car, this hydrogen fuel cell can be run much longer in the driving range than the EV car at the current moment. Also, the refueling time for the hydrogen fuel cell, it will only a short period like a gasoline car, maybe a few minutes, 5 minutes. But for the electric vehicle, to recharge the battery, it will need a long time. Sometimes the shortest is like 30 minutes, and it can only run for 300 kilometers. That's what I ever read so far. The hydrogen fuel cell, it can run with the full hydrogen in the container around double than electrical vehicle. So 700, even 1,000 kilometers, depend on the pressure of the container, hydrogen container. So again, it will be complement each other, Pak Hamdan. So we should not competing between the electric vehicle with hydrogen fuel cell electric vehicle.
Yeah. Okay. One last question, Pak. This is, I think, very interesting from Mr. Ulmer. Do you think, Pak, if we integrate hydrogen production with electricity cost from renewable, where the cost of electricity is less than 4 cents, Pak, do you think it would be competitive?
Hello, sorry. I lost for a few seconds, Pak.
Okay.
Rico, can you repeat?
The question is, do you think it would be competitive if we use renewable electricity for hydrogen production, where the cost of electricity is less than 4 cents, Pak? Do you think it's going to be competitive enough?
Oh, okay.
4 cents, Pak, below than 4 cents.
It's a tough question to answer, because I personally never done the economics calculation for this green hydrogen. I also cannot tell in detail on the NEOM project, which I have some information, because this open to the public. We can always, Ulmer, I offer you, we can always have a conversation between us and providing some more technical information to answer this question. Okay. Definitely, the lower of the electricity cost, that will be more attractive, making more attractive to this project.
Cheaper the better, ya, Pak.
Definitely, Pak. Definitely.
Okay. I think because of time constraint, we have to end the first session. Thank you so much, Pak Tri, for your time and your presence in our webinar. We wish you very good success in our products. Thank you once again, Pak.
Yeah, thank you very much. Thanks for everyone.
We're going to continue to our second speaker. We have Mr. Niels Lancer, Commercial Director from High Gear. Mr. Niels has been the Director of Commercial in High Gear since 2014 until right now. So he has spent more than 7 years in the High Gear. this time, 20 minutes. Mr. Niels, this virtual space is yours. Please.
Okay, thank you very much. Can I share screen?
Yes.
Let me try to do so. I think it's this one. Can you see my screen?
Clearly, yes.
Yes?
Yes,
okay.
Clearly.
Okay, thank you very much, Rico, for your introduction. I will first start with a quick introduction of HyGear. HyGear is a member of the Xebec Group, which is a Canadian clean energy company focusing on on-site generation of renewable natural gas from biogas and the cleaning of waste gases. And HyGear is specialized in small and medium scale on-site gas generation and recycling systems. And as HyGear, actually we focus on the on-site production of hydrogen, oxygen and nitrogen. And we supply these gases in a different way than the traditional gas suppliers, because we do that by on-site generation of these gases at the customer on-site, while in general the traditional gas suppliers produce these gases in large central production plants and truck the gas to the end customer. So I think our method is more efficient, sustainable and cost effective because of our high efficient technology, and we also avoid the trucking part of the industrial gases to the end customer. So as you can see, we have a global presence with our main offices in Canada, the Netherlands and Singapore. And next to that, we have an extensive partner and agent network helping us to develop the market for industrial gases. And as you can see, the partner network is green on the map. And at this moment, we are active in 18 countries. And we have in total 77 installations operational worldwide. We also have a strong R&D background and have successfully developed 14 patents from our system designs. This slide, actually our gas generation technologies are very complementary across our group companies. And in this presentation, I want to highlight the hydrogen generation technology. And in short, I want to mention the biogas upgrading technology and the nitrogen and oxygen generators. And for the on-site generation of hydrogen, we have at HyGear, we have the HyGen SMR system and the HyGen E system. With the HyGen SMR system, that's a steam methane reforming system. We produce hydrogen by steam methane reforming of natural gas. And the HyGen E is actually an alkaline electrolyzer system. And in this system, hydrogen is produced by using electricity. And all these systems, except for the two largest electrolyzer systems that we offer, are built inside a container and can be easily installed at the customer on site. So we have in total 4 groups of applications. The first one is the biohydrogen. With this technology, we produce renewable natural gas from biomass and use this gas to produce green hydrogen with our SMR technology. So the second application is hydrogen energy, where we use our technology to develop hydrogen filling and fueling stations for cars and buses based on fuel cell technology. And the third application, these are the industrial gases, hydrogen, nitrogen, and oxygen that we generate on site at the customer. Regarding this group, the most important markets we are active in are the float glass industry for creating the protective atmosphere in the tin bath, for the production of glass, the metal sintering, annealing industry, the food industry for the hydrogenation of oil and fats, the electronics and the semiconductors. The fourth application is the medical oxygen, where we supply small oxygen generators for medical purposes. So this is actually our business is as follows. So what we do is we offer turnkey sales. This means that the customer can buy the system. In this case, we can do the installation and the commissioning, and next to that, we can also offer a service and maintenance contract. The second important part of our business is the gas as a service construction. And in this construction, HyGear will do the investment and the customer will pay for the gas produced from the system. So the customer then can pay a variable fee, which is dependent on the amount of hydrogen that is produced, and the monthly fixed fee, for example. Only a fixed fee or only variable fee is also possible, and everything in between. So we are really flexible in the contracting. Important in these type of contracts is that we guarantee 100% reliability of supply, but I will later explain how we do that. An important part of our business and also our corporate strategy is the development of decentralized production hubs. We call them DPHs. And what we want to do, we want to create actually a network of small hydrogen production plants on different locations close to the customer. And then from these locations, we can either truck in the hydrogen over a short distance or supply the hydrogen via a pipeline. And we are planning to develop these decentralized production hubs in Europe, Asia, and North America. So what we have, the hydrogen generation systems are built inside a container. This is an example of the steam method reforming system. So they have a capacity between 41 and 141 normal cubic meters per hour, and a purity range between 2.5 and 6.0. So also you can also use them for fuel cell applications. Outlet pressure is between 1.5 and 7 bar, and there is a modulation rate between the 10 and 100%. So as you can see, the systems are built inside a container, built in the Netherlands. They can easily be transported to the end customer, and we can install them over there. So to give you an idea of the process, very basic, we'll go through this. So what we have with steam method reforming is we have natural gas going into a desulfurization system. So we take out the sulfur. Then this gas goes into a steam boiler. The gas is mixed with steam. Then this mixture goes into the reformer and is heated up to a temperature between 650 and 700 degrees centigrade. Then hydrogen is produced, and the reformate goes to a water gas shift reactor. So that's actually a system where we even produce more hydrogen by adding water. It is an efficiency step in the whole process. So this reformate goes to the pressure swing adsorber, the PSA, and the hydrogen is separated from the other gaseous components and is stored in a hydrogen buffer. It's actually a small buffer only used for the pressure control inside the system, but also to deal with small fluctuations at the output of the system. And the off gas is stored in off gas storage. And this off gas is used to feed the burner. And the heat of the burner is used to make the steam. So what you see is actually we try to make use of all waste streams as good as possible, and only natural gas is used to produce the hydrogen. So that's the reason why it is a high efficient system. So we have three different models: the 50, the 100, and 150. And what you see is the purities between 2.5 and 6.0. What they need natural gas as an input, electricity, water, that can be normal tap water, and compressed air for the control of the falls. Also interesting to mention is that they are built inside a container. The smallest one is built inside a 20 feet container. The hydrogen 100 and 150 are built inside a 40 feet container. Okay, then we have also one of our technologies are the electrolyzers. So we have small scale electrolyzer systems in a capacity between 10 and 250 normal cubic meters per hour, and the purity rate between 3.0 and 5.0. The output pressure is between 3 and 30 bar, and the modulation between 20 and 100%. What you see is this is actually an alternative for locations with sustainable electricity sources, so that we can, or if no natural gas is available, then you can also use the electrolyzer system to produce the hydrogen. These systems are also built inside the container, except for the two largest one who are built, who are skid mounted. So this is a basic scheme of the process. It is based on alkaline technology. So what we use is normal tap water. So we have inside the container, there's also a water treatment system where we produce the demineralized water. The water is mixed with lye. That's actually the catalyst for the process. So this mixture goes into the electrolyzer. The hydrogen is produced. The oxygen is produced by the use of electricity. Then the lye is separated from the hydrogen and is sent back to the lye preparation section. That's the same for the oxygen separation. So you don't use the lye in this system. Then this gas stream goes to the TSA, where we take out the water, and then we have the pure hydrogen that can be used by the customer. So that's basically the process. And the systems that we have are in the range between the high-gen E10, producing 10 normal cubic meters per hour, up to the 250, producing 250 normal cubic meters per hour. And it's important to understand that if you need higher flows of hydrogen, then you can place more systems in parallel. And that's also what we prefer to do with customers, because then you create redundancy. Okay, I just want to short point out the gas recycling systems that we have. So this is an example of the high rack. So what we do actually, for example, in the glass industry, you have a mixture of hydrogen and nitrogen. And what they normally do, they vent the gases into the air. And what we do, we capture these gases and we isolate the hydrogen and the nitrogen in such a way that these gases can be used in the process again. This is the high pure, and this is actually a system where we purify contaminated streams of gases where we also have hydrogen. So we can make pure hydrogen from these gas streams. And also very interesting is the biostream system. It's a biogas upgrading system where we can use landfill gas and biomass to upgrade these gases to natural gas quality. And the interesting thing is that we can use these gases also in our SMR technology. So in this way, you can also produce green hydrogen with SMR technology. So to summarize, why on site? There are huge cost savings. Reduce emissions because you don't have the trucking. It's a high efficient system. Increase safety. The reason for that is because you produce on site means that you don't need large storage capacity of hydrogen, and it is completely automated system, so there's no human interaction, which also introduces a risk. So that's what you don't have. It's a very reliable supply. I will come back to that later to give you an example about that. It is a high energy efficient system. It's very compact, modular system, so you can place more systems in parallel. It's autonomous, remote monitoring. There's always an internet connection with our service team, so we can always monitor the system and operate the system from a distance. And independency is also important, that we are not dependent on a third-party supply. So regarding cost reduction, what we see is, for example, that if you have consumers with low consumptions, let's say 20 normal cubic meters per hour, then it's more cost effective to truck in the hydrogen. But at the moment that you go higher than the 20 normal cubic meters per hour, then it is more cost effective to use a hydrogen system. So what we do, you see a dramatic decrease in costs if you use on-site generation, and if the utilization is higher, of course, the costs per cubic meter hydrogen is lower. If you go a little bit higher, then you can combine a tube trailer with the hydrogen, and then at a certain moment you can introduce a second hydrogen system, which will lead again to a cost reduction. So there, in this way, you can go up to around 700 normal cubic meters per hour, and then you will see that you will always be under the price, lower than the price of trucked in hydrogen. So reliability of supply is very important, because if we cannot supply 100% reliability of supply, we don't have a business. And we have a 3-layered approach for that. So the redundancy, the on-site backup, and the trailer backup. This is an example of a typical site. So what we have is 2 generators on site, which creates redundancy. That means if one generator fails, we can always use the other generator to supply the hydrogen. The generator is also used to fill the storage with a compressor, hydrogen compressor. So during maintenance, for example, we can use the hydrogen from the on-site storage. And the 3rd layer is a trailer backup, is that we have our own tube trailer fleet, which we can use to supply backup if necessary. So we have many sources in Europe and Asia where we can fill our tube trailers, and we can always supply the hydrogen via a tube trailer if this is necessary. So also the safety aspect is important, especially when you talk about hydrogen filling stations in areas where people live. What you see here, this is an example of a filling and fueling station in the Netherlands. And what we did a quality risk assessment. So what you see here is these circles represent this is actually a safety area. So inside this circle, there's a higher risk of an incident. So the smaller the circle, the safer the system. And what you see here is these are the tube trailers. Here we have the storage, and these are the hydrogen systems. That the circles around the hydrogen systems are very small, and around the tube trailers very high. And the reason for that is that there's a large storage capacity in the tube trailer. That's one. And the second point is that there's always human interaction, because you have to connect and disconnect the hoses, for example, and that introduces a risk. So that's not the case with the hydrogen, because there's no human interaction. It's fully automated, and there's not much storage inside the system itself. So in urban locations where people live, it is advisable to use hydrogen system for the hydrogen generation for fueling station, for example. So a unique customer-centered approach. So HyGear is really strong in the customer engagement, the technologies and the support. We establish actually strong partnerships with our customers, and we are flexible in the contracting. And regarding the technologies, we can offer the complete product range of gases that are needed for most production processes by using on-site generation technologies. Technologies are really complementary, so that we can offer you always the best solution, and our technology is proven in a wide range of industries and very reliable. And next to that, the technology is cost efficient and environmental friendly, and we have a 24/7 service team available on different locations of the world, so we can always serve you in the best way. And all our systems, what I already told you, have an internet connection with the service team, and they're immediately notified when something goes wrong. And in 95% of the cases, the service engineer can fix the problem from behind his laptop. And if this is not possible, he will visit the customer to solve the problem. So I'm almost there, I think. Some possible configuration. This is a typical configuration of a production site at the customer. So we have 2 hydrogen systems in combination with a storage and a hydrogen compressor, which is used to fill the storage from the hydrogen produced by the generators. So this is a typical site, and you see this is the footprint for this site. You have around 20 meters times 35 meters, so it is a relatively small footprint. Some examples. So what we have here, this is the filling site in the Netherlands. What I showed you, the quality risk assessment was also based on this site. So what we have here is the tube trailers. Here we have the bottle racks, the storage tubes, and here we have the hydrogen systems producing the hydrogen and the compressor system. So this is a typical site for filling tube trailers and bottle racks. This is a site in Turkey. There we use the hydrogen for the lubrication of oils. The hydrocracking plant in Turkey. So what we have here is quite a large site. We have 2 hydrogen 150 systems in combination with a large storage and the hydrogen compressor to increase the pressure to 30 bar for their process. So this is in Philips in Turnhout in Belgium. So you see they are placed very close to each other. So that's also possible. And here we use them also in combination with tube trailer, because they need a little bit more than the system can supply. So then we use our tube trailers to supply the extra amount of hydrogen. This is the site. It's a glass factory in Spain, where we also have 2 systems in parallel in combination with storage. This one is in Russia, where they have 4 systems in parallel. They actually use for the process 3 systems, and they have the 4th one in spare. So if one system has maintenance, they can use this system to produce the required amount of hydrogen. This one is in North America, plug power. For Walmart, we supply the hydrogen for the forklift trucks. It is a warehouse. So they have a lot of forklift trucks, and what we did actually is that normally they use batteries for that, but they took out the batteries and they replaced it with fuel cells. And the fuel cells, they need hydrogen, and so we produce the hydrogen and we supply the hydrogen to this customer. And then the last one is that we also built, as an example of a refueling station in the Netherlands, where we use our technology to fill buses and cars with hydrogen for transport purposes. So this is in very short what I wanted to show you what we do and the role that we play in the development of the hydrogen economy. So thank you very much for your attention.
Thank you. Thank you, Niels, for your presentation. I think we get a very interesting presentation, about modular hydrogen that, perhaps can be implemented in some of Asian countries, including Indonesia. So we go straight to the questions, Niels, that already came in. There are several questions. The first question is from Andre. The question is, how much the cost of production hydrogen per kilo for 20 megawatt modular on site using electrolysis? And I think this is still related. What is the level of methane purity required and CO2 limit for hydrogen system? Please, Niels.
Yeah, okay. First, go to your second question. We have actually certain specifications for natural gas, but almost all natural gas quality in the world is suitable for our systems. Because in the Netherlands, we have the worst natural gas, I guess, in the world, and it's working perfectly in the Netherlands. And in other areas in the world, we see that natural gas quality is much better. But we always need to know the natural gas specifications, because if there is something outside the spec, then we can always change the system accordingly. So, but I think in 99.9% of the cases, we can use the natural gas that the customer has on site. So that's normally that's not a problem. Your first question regarding the price for, if I understood you well, for the production of hydrogen from electrolyzers per kilogram, that's a very good question. That's of course dependent on different variables. The most important one is the cost for electricity. I mean, if electricity costs are low, the total cost of ownership for hydrogen is also much lower. But to give you a rough estimation, I think using electrolyzers for the production of hydrogen, I think it will be around 8-9 euro per kilogram. But that's a very rough estimate. It is higher than SMR. SMR is much more cost effective. Because it is a more efficient system. But if you want to know the exact figures, then we need more information to give you this price.
Okay, of course. Okay, Mr. Andre, if you can contact Mr. Niels, yeah, if you have strong
Sure.
interest, yeah, developing your own hydrogen station or
Yeah.
production. Also from Mr. Andre Niels, how does High Gear see the potentials of Asian hydrogen market? And from all your projects, what system most used, SMR or electrolysis? Please.
Yeah, in this stage, SMR is most used. And I think there are many opportunities in the Asian region. You see that travel distances for transporting hydrogen to the end customer are really long in general, if you talk about countries like India or China. So it is really has a strong cost effect to use on-site generation, because then you avoid the trucking in of hydrogen. And you see that is, of course, the economies are really growing very fast. So there's a lot of industry, and that's also growing. Also needing hydrogen, of course. So we see a huge potential for our technology to supply hydrogen in the most effective way. And also the whole development of fueling station and the transport, the sustainable transport is high on the agenda, most politicals. So that's also important for us, that we can also work with these partners to develop hydrogen fueling stations. For fuel cell transport, transport where they use fuel cells. So I think there's in general a huge potential in Asia. Absolutely, yeah.
Okay.
Yeah, maybe I can add a second point. That's because what we see is urban population is also is expected to grow almost 3 billion in 2050. Recent studies show that, and so there's a lot of solid waste in these areas, and we are talking about 1.14 kilograms solid waste per person, and that adds up to about 3.5 billion kilograms solid waste per day. And what we have the bio upgrading, the biogas upgrading system, so we can use this solid waste to upgrade the biogas that is produced from that to natural gas quality, which we can use again for the production of hydrogen. So if you talk about green hydrogen, this could be a very effective way to produce green hydrogen in a very cost-effective way. Yeah. That's also what I wanted to mention. Yeah.
Great. Thank you. I think I got one more question, the last question, yeah, ladies and gentlemen, I think because of time constraint. The question from Mr. Dreesen, will hydrogen for forklift trucks in distribution centers be an interesting market for High Gear? Please, Niels.
Yes, absolutely. That's what we already did for Walmart and Amazon in North America, because you have to imagine that, for example, a distribution center has 100 forklift trucks. They can use effectively 50 forklift trucks, because the other 50 forklift trucks need to be charged because they are electric. So if you use fuel cell technology, they can very quick fill their tank and start working again. So that means instead of 100 forklift trucks, a company or a distribution center needs 50 forklift trucks. So that's a really interesting cost reduction for them. And at the same moment, they also contribute to the sustainability of the company. So it is really a win-win situation. So for a distribution center, it is really interesting opportunity to use hydrogen for their forklift trucks.
Okay. Again, time constraint. Thank you so much, Niels, and all of you from High Gear. We wish you very good success and stay healthy.
Okay. Thank you.
Thank you. Okay, we will continue to our next speaker, ladies and gentlemen. Mr. Matthew Gies. Matthew is a vice president at HDF Energy. Matthew will explain to us and talk to us about the utilization of hydrogen for power generation. Please, Mr. Gist, this virtual space is yours.
Hello everyone. So thank you, Patrico, for the invitation and the introduction. I will share my slides to introduce who is HDF and how we can make green hydrogen projects happen in Indonesia and in Asia region. Oh, my screen is frozen. Yeah, can you see my screen now?
Yes, but clearly.
So a few words on the company first. So HDF Energy is a French company, as you can hear, but we are a developer and IPP of power plants. So our job is to develop projects, to invest into those projects, to handle the construction and operations through contractors, and we remain into the project life during the whole duration. We are developer and IPP for power plants which are including hydrogen components. The last 2 weeks, we finalized the fundraising in France, a quite important one. We went through an IPO scheme and raised more than 115 million euro through mainly two strategic shareholders. They are from oil and gas sector. Ruby is an oil distributor, while Terega is involved in gas infrastructure. What is interesting about Terega is that Terega belongs to GIC, the sovereign funds from Singapore. So we talked a lot about hydrogen today, and I believe many of you had the opportunity to follow other webinars, so I will be short on that slide. The beauty of hydrogen is that it's versatile. We can decarbonize many sectors through green hydrogen, and that is wonderful. What can be confusing is sometimes what are we talking about when we talk about hydrogen? Are we talking about mobility, industrial application, power sector? When we are a country, what should be the first step into green hydrogen development? Our view is that for a mid-income country, the power application could be a good first step because it allows to develop commercial scale green hydrogen projects without subsidies in the right context. So HDF is focusing on the power application. In the meantime, we can see that worldwide there is a momentum for hydrogen. Many countries have developed a kind of national plan to make green hydrogen projects happen. That is wonderful because it means that the cost will go down. It's not a question mark, it's certain, it's just a question of time. When we see the numerous pilot projects in Japan, Australia, Europe, and the US, there is no doubt that the suppliers will increase their capability and will diminish the cost. And that is key for developers like HDF. As I said, we are focusing on power sector, and we are addressing power sector with two types of projects. One is called Renew Stable Power Plant from renewable energies for firm stable power. The second type of projects we propose is high power. From hydrogen, we deliver electricity thanks to a fuel cell. I will focus mainly on the Renew Stable Power Plant because this is the type of projects we develop in the region. And I will finish at the end by how we can work also on sector coupling, how power sector and maritime sector could have synergies. A few words on the renewable energies context globally, and then more especially in Indonesia. Renewable energies is super cheap now. There is a great return on experience. It's easy to develop projects and to implement them. The difficulties is that it's intermittent power and non-dispatchable. So especially on small grids, it can be difficult to develop renewable energies. As an average, most of grids, they can develop easily up to 20%. Above 20% is thought to have strong impact on the grid management issues, and larger the penetration is, stronger the difficulties will be for the utility. In Europe, for instance, the difficulties are less obvious because the grids are interconnected. So when Germany is developing 30% of renewable energies on their grid, they are interconnected with many other countries like France, like Belgium, and many others. So when they have excess of wind, they can sell it. And despite that, several times during the year, they have negative price in Germany. While when you are an Indonesian island, it's more difficult and even impossible to sell that excess of renewable energies. So that is the context. With the renewable power plant, we can help to integrate up to 80% of renewable power without disturbing the grid stability. In Indonesia, I will make the context simple, and I do believe the context explains the difficulties that PLN is facing for developing renewable energies. On one hand, you have the large grids, Sumatra, Java, Bali, Kalimantan, Sulawesi. You can have affordable coal and gas. Nowadays, you may face overcapacity because also the COVID context. But for a country like Indonesia, when you benefit such amount of coal and gas resources, it could be the cheapest way to produce electricity on the very large grids. In the meantime, you have East Indonesia, where the grids are much smaller and where it can be difficult, even impossible sometimes, to bring the coal and gas locally, because you have to set up an ad hoc infrastructure for the LNG, and that is not economical feasible when the grid is too small. That's why in East Indonesia, but not only, worldwide, in grid island context, it's very expensive to produce electricity because you cannot use cheap power. In the meantime, when you want to develop solar and wind farm in Indonesia on the west, we need to fight against coal and gas. Sometimes it can be difficult, depending of the context. And in the east, there is the technical challenge of intermittency. And for PLN, and this is the same in other countries, in similar context, it will be difficult above a certain level of integration to handle the intermittency. And I do believe this context explains why the country has been struggling with renewable energies. Hopefully, the cost of solar and wind is getting lower. So step by step, it should be able to fight against coal and wind. And in the East, we believe that the renewable power plant could be one of the answers to address the intermittency factor. What is a renewable power plant? This is a plant where we combine PV or wind or both to batteries and hydrogen. The hydrogen is produced on site. So it means we will tackle the logistic challenges that the LNG or the coal is facing to deliver power in remote areas. So we produce the hydrogen on site with an electrolyzer. We store the hydrogen on site with tanks, and the hydrogen becomes electricity at night with a fuel cell. So the whole plant is 100% logistic free. And in the meantime, it can deliver a firm and stable power at a high capacity factor, minimum 80%. It can include many grid services to be sure that PLN won't have grid stability issues in the areas where we develop our projects. And the sizing is very flexible. The unique constraints we have is to deliver 1 megawatt capacity at night. And then at the end of the day, it's just a question of reciprocal commitment in the PPA. So at the end of the day, those power plants, somehow they are very similar to what a thermal power plant will do, because the capacity factor is high and we deliver commitment on the stability of the system. So the benefits, I will focus on two, and it's very obvious. On one hand, we will have to reduce the local cost of electricity. We address remote areas, and in remote areas, most of the electricity is produced from diesel genset. It's quite expensive. So we will reduce the dependence on diesel gensets, and hence we will reduce the average cost of electricity generation. In the meantime, we will enhance the grid stability. And it's very important to address both topics in the meantime, because you can tell that you are very cheap, but if your system is unstable and bring troubles to PLN, it doesn't matter whether you are cheap or not. It's not interesting for the system, and vice versa. So on our side, we address both items in the meantime. I will give you an example of a project we are developing in France. So this is in a remote area of France, in French Guiana. This is surrounded by Amazonia forest and the sea. So like PLN in East Indonesia, but the utility there is called HDF. They struggle with intermittency. They struggle to diversify the local mix. The cost of electricity generation there, it's quite high, while the capacity installed is 300 megawatts. So our power plants are a way to help to diminish the dependence on diesel gensets. We are ending the development. Hopefully the construction will start soon. What is interesting on that project is not the numbers, is that the fact it's a commercial scale project. The capex is above 100 million euro. So this is not a pilot, this is not a demo, this is a commercial scale. The equity is financed only by private stakeholders. There is no subsidies involved. So HDF is part of the equity investors. Then we have Meridiam, an infrastructure fund, and Sarah, a refinery owner. While the debt will be brought by a development bank. EIB board confirmed they will bring up to 40 million euro. Then the other banks will be commercial banks. So that is the key information on that project. The commercial scale, this is not a pilot, this is subsidy free, and lenders, whether they are DFIs or commercial banks, are comfortable with the technology, with the scheme. So this is this type of project we are developing in Indonesia, the Philippines, and other countries of the region. And we can demonstrate it's bankable thanks to that project. So our ambition is to develop these projects to duplicate that in East Indonesia. We are looking also at Philippines, where we have a presence locally, and other countries of the region. We do believe it can be a part of the answer to diversify the mix in remote areas when there is no or few hydro or geothermal resources. I will explain now quickly the other type of projects we do and might do in Indonesia. So there is the high power projects. From hydrogen, we will produce electricity, whether the hydrogen is green or blue. So this is a way in Europe, for example, to replace gas peaker plants. If we want a grid to become 100% CO2 free, we need to replace gas. And the high power plants can play that role. It can be also a way to address shore power and industrial needs. As an example, we have a reference in the petrochemical plant in Martinique Island. This is a French island in Caribbean, where we use the excess of hydrogen from the refinery to convert that into electricity. And such application can be used for captive power, or we can sell the electricity to the grid, depending on the context. And that is economically viable. We can produce electricity below the national average cost in Indonesia. Lastly, I would like to talk about sector coupling, especially for Indonesia. It could be an interesting approach, and also for the Philippines. So we explained how a renewable power plant can accompany the diversification of a remote grid. But in the meantime, those areas, they are highly dependent of maritime sector. for tourism, for commercial needs, for industrial application. The maritime sector is very key in those areas. If we want to decarbonize maritime sector, the only way would be to use hydrogen as a backup for power, to decarbonize ferries, or for the local mobility. Due to the versatility of hydrogen, it will be a great and a unique way to decarbonize those sectors. While there is a real synergies between the renewable power plant and the maritime sector, developing a renewable power plant in remote areas means that the green hydrogen can be available locally. And developing both in the meantime would help to diminish the incompressive cost for the maritime sector, the cost of development, the cost of infrastructure, the cost of O&M. When it's merged with a larger commercial scale projects, it will bring down many costs, and it can help to make the maritime application quite sustainable and affordable. So that's it for the presentation. You have our contact details there. You are free to reach us, and thank you again, Patrico, for the invitation.
Okay. Thank you so much. Interesting presentation from Matthew. That I think is going to be the pioneer of hydrogen power plant in Indonesia if it's realized. So straight to the questions, Matthew. There are several of them. The first question is from Mr. Andre. To HDF, what electricity price you are looking to be sold to your power buyer? And yeah, maybe that's it first.
For us, our first step is not what is the electricity price we can deliver, because it will depend on the context and the sizing. And if I disclose a number, it could be counterproductive, because again, it depends on the context and the needs locally. So for us, what is key is to understand what are the local constraints for PLN in terms of grid diversification, in terms of diesel replacement, potential for growth, the load of the demand, and so on and so on. Then we can size a project and propose a price. What I can tell is that our ambition is to always help to decrease the local cost of electricity generation. So we will be below the BPP in East Indonesia.
Okay. So answering Pak Andrea, so it will depend on the local need and also the local load of the area. So, but of course, it will be lower than the BPP. Okay. Second question, Pak Matthew, from Mr. Drisan. Oh, sorry, from Pak Rahmat first. What about LCOE of hydrogen for power generation compared to others? For example, in natural gas. Yeah, please, Pak.
Well, the question is a bit similar than the previous one, but indeed, green hydrogen is more expensive than natural gas. I won't lie. I won't explain that it's cheaper than natural gas today. If you want cheap power, please use the coal, use the gas. It will be more competitive today on the very large grids, and that's why many countries which rely on coal and gas, they have difficulties to diversify the mix, because unfortunately it's quite affordable. Though we need to include the externalities of the coal and gas and to see the full picture. That being said, the problem you have in Indonesia, but also in Philippines, in Pacific Islands, or in the French Islands, is that when you go to islands, when you go to grids which are below 1 gigawatt, 500 megawatt, and the lower it is, the more it's true, is that it's very complicated to deliver the gas there. You need to set up LNG infrastructure, so you need to liquefy the gas, to transport the gas, then to regasify the gas, and so on and so on. It's expensive. It has incompressive cost. And in islands, when the demand is not large enough, basically the gas is never arriving there because it's too expensive to bring the gas locally. So at the end of the day, the question is not whether green hydrogen in our approach is more affordable than gas. Clearly is not, but there are many areas today where the natural gas cannot be delivered. And this is these areas that we are targeting.
Yeah, okay, very clear. And maybe the last question, Matthew, from Mr. Driessen. From engineering point of view, is the system developed that you develop in such a way that local people in remote area can maintain or repair the system if maybe it's broken, but hypothetically, yeah, please.
So we have indeed we have many questions regarding those topics. It's often related to the fact that people are wondering if there is the local know-how to maintain the system, but also quite frequently the guys who are asking such questions, they had bad experience with pilot scheme. You know, you do a pilot in the middle of nowhere, everyone is happy, and 6 months later, no one is in charge of the maintenance. While the developer of the pilot said, "Don't worry, you don't need maintenance; it will work for 100 years." In our approach, so we are developer and IPP. We are owner and co-owner of the project, and we handle the O&M during the whole lifetime of the project. So for us, it's a question of project management. We structure the development to be able to address that topic and to be sure the right resources will be available locally, whether by sending someone qualified over there or by doing training, by implementing partnership with the regional university and so on. So we can bring an answer to that topic.
Okay, so for the maintenance, the local resources can be trained or educated, yeah, Pak, yeah, for
and this will be our commitment to make that happen.
Yeah. Okay. Thank you so much, Mr. Matthew Gies, for your presentation. And I think we go straight forward to the panel session with Mr. Niels Lancer. We're gonna wrap up our webinars today. We're gonna explore 3 main topics. I think Mr. Lins, can you join with us again?
All right. Okay.
Okay. Thank you, Mr. Neil. So, in this panel session, gentlemen, ladies and gentlemen, you still can ask questions, but I will bring 3 main topics that will be explored in this panel discussion. The first question that I want to ask to these 2 gentlemen is, what do you see on the Asian hydrogen market, looking at the opportunities and challenges, having your portfolio, having your services that being offered? Maybe from Mr. Niels first, please.
Yeah, it's an interesting question. Actually what we see in the Asian and global, we see Asian actually as a global hub for manufacturing and trade at this moment. And most of the hydrogen demand is in the industrial sector, like glass manufacturing, steel industry, and also semiconductor industry. And what we have seen, recent studies have shown that SMR is actually still the most common way to produce hydrogen from natural gas. And advantages are low cost, high reliability, and environmental advantages. And especially when using on-site hydrogen, these advantages will even be bigger since you avoid trucking of hydrogen. And we already have worked with many customers in Asia and offered them solutions to reduce these costs and increase the reliability of supply. So especially the growth in industry in that region is really an incentive for us to develop the business over there. And what I also mentioned to you was the growth in the growth potential, the urban population producing a lot of solid waste. I think it's really important to realize that this waste can be changed to biogas, and this biogas can be very effectively used to produce the hydrogen. And that's also what we see as a big opportunity in the Asian region. And the last thing is, I think I wanted to mention in this respect, because that Asia is a really important growth sector for the automobile sector. A country with a focus have a focus on decarbonizing and replacing petrol and diesel vehicles with fuel cell vehicles, and in this way, emissions of CO2, NOx, and dust can be strongly reduced, as we see. So there are many initiatives at this moment to develop hydrogen fueling stations, and these stations need hydrogen. So, and I think that our technologies make it possible to effectively supply hydrogen on location. And this is perfect in line with our strategy also to develop DPHs. So developing a hydrogen network of small hydrogen production sites in the vicinity of the fueling stations. So there are many things that are important for us in this region to develop the business over there.
I will bring some views on that question. I won't repeat how HDF can accompany the development of hydrogen. I think I made that clear. My view in Asia is that we have two types of country. The ones who can afford to pay premium today to develop green hydrogen projects to help to decarbonize many sectors, data centers, grids, heavy mobility. And there are the other countries. So for the first category, I believe that Japan and Singapore can take a role of leadership to make the first projects happen, to help to create a local return on experience, know-how, to help to decrease the cost. While for the mid-income countries, it will be challenging to play a similar role because for many applications, it's kind of expensive to do green hydrogen projects. And I'm not sure that Vietnam, Cambodia, the Philippines, Indonesia would see that as a priority. That being said, we can also focus on applications which are commercially viable. And this is what we try to do as HDF, is to demonstrate that we can do commercial scale green hydrogen projects today without subsidies in the right context. And this is what we propose to Indonesia.
I cannot hear you, Rico.
You are mute, Rico.
Okay, I think you two make a very interesting perspectives on the Asian market that despite the diversity of economies, both of each countries in the Asia has potentials to adopt the hydrogen, yes. And knowing that also the population in Asia is increasing rapidly. Niels also mentioned about the potential from solid waste going to be produced in the future, yeah, and it can be converted into biogas, and then the biogas can be converted into hydrogen. And I think I'm going to ask the question as what aspects or maybe regulations, if you may say, that must be done or improved to enable hydrogen to be implemented, to be engaged in Asian. From Pak Matthew first, maybe.
The question is very important. The topic is key, but my answer will be, I think, quite short. It's just we need to find a way to for the regulation to be friendly with developers, with projects under development. We need to see how the current regulation can be in line with those projects. If we want to create local know-how and a return on experience, we need to have some flexibility on the regulatory side. And in the meantime, the governments can prepare the long term for when green hydrogen will be a commodity and can address many sectors. But on the short term, we need to be able to make the project happen somehow.
Okay. Niels?
Yeah, I think one of the most important things is that there should be awareness. That's, I think, the key word. There should be awareness in society that hydrogen is the way to go in the future. Industry and government, and they need to accept that hydrogen is very important in the energy transition towards a sustainable environment. And next to that, I think that society also needs to accept that other ways of hydrogen supply has many advantages. It's always difficult to change from a traditional concept of hydrogen supply from central production plants to the much more innovative concepts of hydrogen supply by on-site generation, for example, or electrolyzers. So I think this needs time, and our mission is also to prove society that we can do that in the most effective way. And in addition to that, I think it's important that governments stimulate the development of the use of hydrogen more through the financial support, because I think this will really accelerate the transition from fossil fuels to sustainable fuels and energy carriers. And I know there's still a considerable task ahead of us, but that's what we are working on. And that's, of course, also in relation to the first point I mentioned. If there's more awareness of the advantage of hydrogen and the technology itself, I think the financial support will also be easier to get and to be developed by these governments.
Yeah. Okay. I think I totally agree with all the points. Yeah, about the flexibility on the regulations. Of course, these governments that tend to be sticky, on their regulations, but we expect that to be happen. And also awareness. I noted that Niels mentioned about awareness. That that's one of part of us to explain to the people, the benefits, the advantages of hydrogen, and also the modularity that can be independency that can be obtained by each region. Yeah, and maybe the last question, ladies and gentlemen, for Niels and Matthew, the view of coloring of hydrogen that right now everybody's debating. It must be blue, or it cannot be gray, it cannot be blue. Should we maintain the view, ladies and gentlemen? From Matthew first, maybe.
Yeah, on our side as HDF, we focus on green hydrogen. When we talk about renewable power plants, it's green hydrogen only. That being said, I do believe it's important to also focus on blue hydrogen. I will explain quickly why. Firstly, if we want the hydrogen devices cost to decrease, we need a scale, we need a numerous amount of projects, and that will happen if we consider many color, maybe not gray, but blue, green, the one with nuclear, I don't know sometimes if it's yellow or green or blue, but we need to consider all the colors which are environmental friendly, because it will help to bring the cost down, and this is the priority of the sector. And also regarding Indonesia, there are a lot of coal and gas resources. There are coal assets in operation, and they will last. They won't be off in the next few years. So maybe there is something to do with CCS technology to manufacture blue hydrogen, who will be sustainable for the environment and might be competitive also. I do believe that could be one of the strategy of the country to develop hydrogen, and that would help the scale development I was talking about.
Okay, Niels?
Yeah, I think that the hydrogen colors are always to differentiate the hydrogen production and supply method in relation to CO2 emissions, of course. And what my experience is that it's always the perception of the customer also, because you always have to discuss with them. Okay, you want green hydrogen. What do you mean with green hydrogen? What is your definition of green hydrogen? And it is actually different for each customer. That's very funny always. So I always try to explain. And now I see this question. Maybe is it possible that I share my screen, because I have a very interesting slide where it is explained. Is that okay?
Yeah.
Okay. That is actually this one. Can you see it?
Yeah.
All right.
Really.
So what you see here, this is actually our definition. So we have the gray hydrogen is produced from water and natural gas, or water of the current electricity mix. Then we have the gray hydrogen. Then we have the blue hydrogen. That's the water and natural gas, water and the current electricity mix. Then we capture the carbon and we store it. And that's the blue hydrogen. So that is actually CO2 emission free. Then we have the green hydrogen. produced from renewable electricity and biogas. Then we have also zero emission hydrogen. That's what we call green hydrogen. Then this is actually our own color. It is a mixture of blue and green, and we call it cyan hydrogen. And cyan hydrogen is actually the combination of water and biogas, and that in combination with carbon capture and storage. And in this type of hydrogen, you get a negative CO2 emission. So that's even better. So then you will, a negative CO2 emission. And then of course you have the waste hydrogen. Does not really have a color, which is produced from waste hydrogen processes where we clean the hydrogen and where we capture the carbon. And in this case, we also have a negative CO2 emissions. So this is always what I show customers, telling them, and then actually all these things we can do. So it's always a very interesting discussion, and showing them this picture, it makes them it is most of the times clear for them what they want. So that's actually what I wanted to show you.
Okay. Interesting. When I asked the question about should we maintain the V, I even get new color today, from Niels. Okay, interesting presentations from all speakers. Thank you so much, Matthew. Thank you, Niels. Thank you also, Pak Tri from Air Products Indonesia. And thank you for all of you who have joined these events. I sincerely hope that all of you get something insightful, and useful for your business, especially in the hydrogen business. And we wish also to all speakers, to Air Products, HDF, and High Gear for very good success to their business in the future. Thank you so much, ladies and gentlemen. I think we're gonna close this today's webinar. If you have any question about the event, you can ask to Petromindo team. Anything, you can contact the Petromindo team in the website. You can find the contact in our website and telephone number. So again, with this, I'm gonna close the webinar. Thank you so much for joining. See you again very soon. Bye bye.
Thank you very much.
Thank you.
Thank you.